Yeah, maybe start from introduction of you. Maybe start from reporting.
Hi everyone, I'm the captain of Online Mission Type American Support. My name is Tom People. This is already you that know me, even I met to the field.
Hi, working Maya. This is殷品义，这是蔡雷，王燕琪、季雅轩，这是李宇璇。
I'm Captain of Variable 1, and I'm杨佑一、严玉彤、陈轩池、陈佑启、侯文清。
Okay, so I'm the chair junior. My name is 林同学 from 中研院物理所。
Morning. Chengdu, my name is Chengdu. Zhou University.
My name is Su Jongwu from National Jiayin University.
Zhong Haoren from National Taiwan University.
徐明，中山大学。
Okay, so the opponent, please challenge the reporter for the project.
We would like to challenge number 50.
We accept.
Okay. So please write your name on that. Okay, recorder, please.
Hi, my name is Danielle Lee, and I'll be representing Team All Niners for problem number 5 lightning bolt. This is my problem statement. When you strike the side of a metal bowl containing some water, you can hear a characteristic sound. The sound changes when the water in the bowl is moving. Explain and investigate the phenomenon. I will be mainly focusing on what is the difference between sounds produced by a still bowl versus a moving bowl. This will be the flow of my presentation. Moving on to the phenomenon investigation. These are the variables that I will be testing, which is the volume of water inside the bowls and the movement or lack of movement of the bowls. There are other variables in this experiment that, like for example, the bowl's parameters like radii, height, density, composition, curvature, varying thickness and size and bottom, and the speed of the oscillation. I will address the bowl's parameters later on, and the speed later on. Firstly, I have to explain how Tibetan bowls, which are the main types of bowls that I will be using, produce sound. The natural frequency of Tibetan bowls are determined by their thickness, material, density, mass, volume, stiffness, height, capacity, curvature, boundary conditions, surroundings, etc. When stricken with a mallet, it inputs energy into the system, which excites the natural frequency of the bowls. These frequencies create pressures in the air that our ears interpret as sound. The vibrational modes, we know that the bowls are oscillating around the rim according to the dynamics of Tibetan singing bowls by the Musical Acoustics Laboratory and Pressure Bowl. Moving on to my theory. The theory is that the frequencies produced by the bowls have a second-order polynomial or quadratic relationship with the volume of water present inside the bowl. And the frequencies produced by the bowls would not change when the water is moving or not moving, only the amplitudes change. I mostly got my theory from my preliminary results, in which I will explain why it's quadratic later, but when I tested volume against the frequencies produced by a still bowl, it showed a quadratic relationship. And when I tested different speeds of a moving bowl, I found out that the frequencies produced were pretty much the same, and the different colors on the right graph represented different octaves. Onto my experiment. I technically have 4 bowls, however I only used 3, and I'll explain the 4th one and why I didn't analyze the 4th one later. This is my experiment setup. The cloth barrier is there to block out some of the background noise produced by the oscillator in the front, right here. And the power box is used to control the current, however, it does not enable me to control the speed. It only allows me to vary it. The microphone is placed within the bowl's frame of reference in order so I don't have to account for Doppler. This is the still bowl's frequency versus volume for my smallest bowl, and as you can see there is a quadratic relationship. This is just another example of using my second largest bowl. Onto the moving bowl section. I used the same audio file and I split it at separate points, which is why it's called segment 1, segment 2, segment 3, and segment 4. And I used the same x-axis for all 4 splits. And as you can see, the same peaks appear in the 4 segments. And the chart over there is color-coded because the same colors represent the same frequencies that pop up all the time. Just to closely analyze one specific example, I placed the amplitude versus frequency of when the bowl is not moving here, and those are when the bowl is moving, and you can see that the same frequencies show up. Now, onto my conclusion. Firstly, the frequencies produced by the bowls have a second order polynomial or quadratic relationship with the volume of water present inside the bowl. This is why I think that is. So the natural frequency formula is dependent on the mass of the object and the stiffness of the bowl. However, that is dependent on specific properties of the bowl. And we see in the chart, in the graph, that the drop in frequency accelerates because when there is more water, the water restricts the vibrations of the bowl slightly more, which increases stiffness. And there is no linear relationship between the mass and the frequency, so that's how we know it's not. And the second part of my theory, that the frequencies produced by the bowl will not change when the water is moving or not moving, only the amplitudes change. Here's why I think that is. So the water moves inconsistently when the bowl is oscillated, which by that I mean that the water does not oscillate perfectly in sync with the entire oscillation system. So the mass distribution and the water movement varies. However, that requires calculus that I'm not very familiar with. And when the water moves inside the bowl, some water moves along with the bowl's vibrations and some against. That means that the water moving against the vibrations absorbs some energy, which creates temporary dampening of certain amplitudes. However, another possible explanation could also be related to the curvature of the bowl and how waves bounce off the curved surfaces inside the bowl to produce distinct frequencies. However, I did not look into the curvature of the bowl, and I'll explain why later. Okay, so a summary of our results is that the frequencies we hear when the bowl is stricken is not dependent on the height of the water, but it is dependent on the mass of the bowl and the water inside. Secondly, there is a quadratic fit for frequencies versus volume of water, and there is no difference in frequency for a moving bowl versus a not moving bowl. Only the amplitude of the different frequencies change, which is where the wailing sound comes from. Moving on to error analysis. There is still evidence of some background noise present because although I included the clock barrier to try and minimize most of the background noise, it doesn't wrap all the way around, so there is still some background noise, and you guys can see that in the chart over here, these areas. And sometimes the same frequencies that I color-coded in the charts next to my graphs slightly differ by around 0.01 to 0.04 hertz. And additionally, my oscillating contraption is not perfectly smooth, like sometimes it has a jolt at the end. And the cards in the track are also not perfectly silent when they're moving, so that is where most of the background noise comes from. And I already addressed the oscillation speed and inertia of the water and the mass of the water not matching up, which results in the water in the bowl not moving in unison. I already addressed that earlier in the presentation. Okay, so I'll now justify some of the decisions that I made when I was conducting my experiment. So the reason why I did not use the fourth steel bowl, instead I used Tibetan bowls, is because I found out that the sound lasts less than 1 second, and it's quite difficult to make a wailing sound out of that, to detect a wailing sound out of that, so that's why I did not include it in my experiment. Let me see if I can play the audio. Oh, no. But how do I get rid of that? Okay, I'll just talk about the rest while the problem is being fixed. So I did not include the Tibetan bowl's parameters and variables because I couldn't measure or vary those elements independently to see how they react differently. And also, the Tibetan bowl's metallic compositions and exact percentages are not made publicly available, and usually nobody knows. So I can't put a definite factor of that into my investigation. Thank you for listening.
Okay, Poland.
Thank you for your presentation. And my first question is, how did you move the ball? You have observation video.
Sorry, I didn't include it.
Okay, so could you please explain how did you move the ball?
Okay, I'll show you my experiment setup. So basically, I put my bowl and water inside bowl here, and then I used a power box to control the current for the
So
motor.
you use the power box to move the ball, right? Am I right? Or
It's like the motor.
okay, so you use the motor to move the ball, right?
Yes.
Okay, thank you. And the next question is, how long is the distance between the microphone and your ball? The distance between the microphone and your ball.
It looks, I didn't measure exactly, but it looks around 30 centimeters.
Okay.
Or,
It's all the same in
yes,
Okay.
yes.
And the next question is, how did you analyze the data?
How did I analyze the data?
Yes.
I mean, how did I
Yes,
extract the
you,
data?
you test the frequency, right?
Mm-hmm.
And how did you analyze it?
I put it into a program where I could extract the FFTs. These are FFT checks.
Oh, did you have the code of this one?
Let me show you.
Okay, so later. And how can you know that in page 7, how can you know that frequency won't change?
Oh, that's from my experimental results.
Is
Like
that-
from my preliminary results.
So could you please explain that? Sorry, and the next question is, would the motor makes any sound? Make the environmental sound?
Yes. That's part of the backup.
Yeah, please.
Okay, so hello everyone, I'm opponent from the variable one, and today I would like to oppose number 15 welding ball. The problem statement is when you strike the size of the metal ball containing some water, you can hear a characteristic sound. The sound changes when the water in the bowl is moving. Explain and investigate the phenomenon. So I think the main focus might be what is the difference between the sounds produced a still ball versus a moving ball. So there is an overview of the presentation. The first one is phenomenon and setup. The reporter used motor to conduct the experiment, but I think the sound of the motor may cause some effects in the result. And the theory, how does the ball produce sound? Is striking with mallets and vibration modes, and they use simple harmonic motion for the period of formula. But I think it's not suitable because the sound is not a simple harmonic motion, and also I'm not sure which one is the simple harmonic motion. Is the motor cause or is the air in the ball cause or the water cause? And next one is experiment. Their independent variable is the volume of water and movement or lack of movement. And discussion. Frequency vary change with low the water move. The peak in the amplitude vibration and not used still because the period less than 1 second. And the conclusion is frequency barely change with how the water move. Only amplitude change depends on the mass of water inside. And oscillation and the internal water didn't match up. So here's our discussion point. The first one is a simple harmonic motion used in the frequency formula. Is that suitable? And change in the water and the air volume in the same time, because I think when the height of the water or the volume of water change, the volume of air will also change. So I'm not sure which one is their data. And set up the method of moving ball, because I think the motor may change its speed, because I don't think there's the constant speed motor. And the sound from the motor may also cause the environmental factor. And change in the frequency during knocking, because I think while striking the ball, the frequency will also change while, yes. And how to depict environmental sound, I want to ask this one. And they analyze data because they use a program, but I don't see the code of that. And I think they didn't separate different sound of a different frequency, because in this experiment they have to separates the frequency by the ball and by the water and by other environmental factor. So and then that's why the height didn't change the frequency. So in the experiment I see that, but in their presentation they say that the mass of flash will change. So I will ask it later. And now I would like to invite the reporter onto the stage. Okay, so the first one is in your problem statement. Please turn to. So my question is, how do you define characteristic sound? Because the problem statement says you have to investigate this phenomenon. So please tell me how do you define the characteristic sound?
Oh, the characteristic sound is.
Sorry, please louder.
Oh, sorry. The way that we define characteristic sound is the wailing effect heard.
It's the frequency of that or what's characteristic? Because the problem statement says you have to investigate that. So what's characteristic?
For us, for me, I did amplitude.
It's an amplitude, but I think amplitude is strong enough for the sound. It's not. I think this one is the frequency. Do you agree with me?
Sorry, could you repeat that?
The characteristic sound caused by frequency. Do you agree with me? Because you said this one is caused by amplitude, but I think it's frequency. Do you agree with me?
No, because my experiments do not show that.
But you test the frequency in your data, right?
Yeah, but then they turn out to be the same.
So I think characteristic sound is caused by frequency because your data show that the sound change and the frequency change. So let's go to the next stage. And in your theory, please turn to page simple harmonic motion. Theory has the one with the frequency, the formula.
Oh.
Yeah, this one. I don't think this one is okay for the experiment. Can you explain that?
Why don't you think it's okay?
I think this one is not suitable. It's not suitable because this one, the sound, the frequency of the sound is not always the simple harmonic motion, and this one is the formula, is the frequency formula in simple harmonic motion. So, what do you think?
Is it like frequency usually related to simple harmonic motion, and that's why it's
I don't think this one because the sound may not be like this one, and this one is the wave shapes of the simple harmonic motion, but in your data I didn't see like this one, so I think you can use this formula to analyze the data. Do you agree with me? Okay, so the next question is, yes, you said you use this one, right? And why do you use this one in presentation? Is the motor of less cost or the frequency of the air cost or the frequency of the ball or the frequency of water, which one cause the frequency different?
cause the frequency difference?
Yes.
But I'm saying that the frequency is not different.
So please turn to the page. You're saying the frequency is not different. Please turn to that data.
No, I mean, which part of the theory are you talking about? Are you talking about when the ball is still or when the ball is moving?
I think the ball is moving.
Oh, okay. This one?
So, okay, at first I want to ask a question. This one is the total frequency of your microphone, right? It's all, all of them.
Yeah.
It is a, so did you separate them? Because the frequency here has very different, has a lot of different frequency, and they totally together to make this one. Do you agree with me? So
Who total together to
this one, because the frequency may maybe the environmental factor, and your experiment data shows this one, right?
This data I got from the microphone.
Yes, because so I want to ask, the question is, this frequency is a ball, or the ball plus water?
Is the sound produced?
Is include ball and water, right?
Yes.
Okay, so I think you should separate it, because I'm not sure this one is, because the ball, well, different, but you have to investigate the phenomena by water, right?
Does it say that?
Yes.
By water.
Yes, the sound might be caused by water. So I think, okay, so next question is, you say the height of water may not change, right? Because the heights may not cause the frequency different.
Here's how I know that, because when the bowl is moving, the water inside the bowl is moving, which
Could you
means.
please show me that?
Okay. Here.
Do you have data about this one? Data?
For this.
Yes.
You mean
I mean the heights and the heights may not cause the frequency change.
you don't have like numbered.
So this one is your assumption or your is your test this one or
It's from my observations because I can see the water.
But in my opinion, I think that the height of water may cause, because when the height of water change, the volume on the water in the bowl may also change. So I think the frequency may change. So do you agree with me?
I'm not sure what you're saying because you said that.
Okay, so may I use a blackboard?
Yes.
So in this one is your bowl, right? Okay. And this one is your water. Okay. Here is water, and here is the air, right? And if you change the height of that, the water, this volume may also change. So I think the frequency may change. Do you agree with me?
Are you talking about like the volume of water changing or the height of the water?
The height of water, because here is the height of water, right?
Oh, I'm saying that the volume will change the frequency, but I'm not saying that the water height itself.
But the water height itself may cause the volume change, right?
The volume, when the volume changes, the water height.
Yeah. That's what I mean. So which one is different from this one? So this one may cause this different. So I think the frequency may also change by this one.
Okay, but however, when for example, the water height is also changing, right?
Yes.
With the frequencies? Let's say the volume.
Do you have data to prove this one?
Yes.
Okay, please show me.
For example, this one, I use the same volume. It's the same experiment.
Yes.
And the water is moving inside.
So
the water height is changing inside even though the volume of water is the same.
So I think while this one, so please explain this chart, because I don't know, but because I'm not sure which one is your dependent variable or your independent variable. So
Okay. So my independent variable is the volume of water present inside the bowl. And this is the same speed. I'm moving the bowl at the same. Because, okay, it's one experiment, so which means I'm using the same speed oscillation. However, I'm splitting that audio file up into a couple of different parts. So the water levels are changing.
so
Sorry. Okay. So that means that according to you, the frequencies should be different in all of these charts, right?
yes.
However, they're not.
Yes, they are different. I think this one is amplitude, and the amplitude might be the ratio of different frequencies. So So the total frequency will not the same, right? In this chart, you also show this one. So can you explain that?
So you're saying that the amplitude difference is because of like.
No, I mean the amplitude might be the ratio of different frequencies. So
You mean like contrast?
so your totally different frequency may be different. The frequency in total will be different. You agree with me?
So you mean like different ones pop up, but they go together to create these different
Yes.
amplitudes?
So this one may be different, right? So in this data, I'm not sure. So.
Time's up.
So, and now I would like to summarize the discussion. The first one is the characteristic sound. Reporters say the amplitude different, but in our opinion, with interchange of the frequency causes the characteristic sound because the sound is different. Because the sound looks different in the data analyzed, the frequency may cause visible. And this one and that one is simple harmonic motion. The reporter said the frequency related to simple harmonic motion. And we think simple harmonic motion has sine or cosine function, but I didn't see any results in their discussion, and I didn't see any fixed function for that. And the data and measured data is the flow or the water. The reporter combined the two together, but the opponents think she should separate the two things because of the first tendency. The water is the main focus. So thank you.
Okay, reviewer.
So on a by reporter, what do you think is the relationship? Can you turn to the screen page? What do you think is the relation between isolation of the spring and the vibration of the ball?
Because the ball, it's like oscillating on the rim, so that's what.
So do you think that they will have the same characteristic with this equation?
Likely.
And what do you think is the most important factor in this phenomenon?
I think the volume of the water is the main factor. Is that
I think that's the result. I mean the factor.
factor?
Yeah.
Factor. No, water volume is a factor.
That's the main factor.
Yes, I think so.
Okay. How about you? What do you think is the most important factor in this phenomenon?
The most important factor is the volume of the water, because that changes the
And the factor and the result.
Yeah, so volume of water, but not height of water.
Okay. And do you think that? So you don't think that the water height will affect the amplitude?
I think the height does impact the amplitude, but not the frequency.
So how do you think the height will affect the amplitude? Or is it more higher than the amplitude?
That is one aspect that I haven't looked into.
How do you think the height will affect the amplitude?
I think while striking and when you strike the ball, the biggest shift is by the water, and the next one and the second one is the air. So I think when the water increase and the volume of air decrease, the frequency may be lower.
Do you think the material of the ball will affect this phenomenon?
Yes, because the material of the ball impacts the stiffness of the ball.
Did it change the material?
Okay, I'll explain that. So
You didn't change the material.
no, I kept that constant because I couldn't control it.
Do you think the material affects?
Yes, I see. Because some different material may cause different sounds in when you strike the ball.
Natural frequency?
Yes.
Thank you very much. And that's all of my question. Thank you.
Reviewer, please have the floor.
Honorable judges and fellow competitors, and the reviewer from Yamaha and Langley's test. So this is a problem statement, and their focus is on the difference between the still ball and the moving ball. And this is an overview from the reporters. They have their observation have compared the still water and the moving water and the speed of oscillation, and their experiment method is use the motor to move the ball and they have 4 balls, but they ultimately use 3 balls. And the data analysis, I didn't see very organized data analysis, and the conclusion is that the frequency won't change based on the amount of water, but the amplitude will change. And the pros and cons of the reporter, they have a clear demonstration and have a clear explanation and a thorough PowerPoint. But the cons is that they lack of organized analysis of the data and lack of experiment data and unclear position and fail to understand the problem statement. And the pros and cons of the opponent is that they have a thorough discussion, like they give a lot of factors, but they fail to have an organized viewpoint, and they misunderstood the reporter's result and fail to explain the idea, like a unclear word choice. And the discussion of the reviewer, the remark from the reviewer is that the opponent have asked, how did you move the ball? And the reporter have answered, they use a motor. And we think that there's a good control of vibration of the ball if they use a motor to move the ball. And opponent have asked that the distance, have they measured the distance between the microphone and the ball? And the reporter said that they didn't measure, but every time the microphone is in the same position. And the reviewer believes that they fail to quantify the distance between the microphone and the ball, but they maintain the same, so they can make sure that it is not a variable. And the opponent has asked that, how do you define characteristic sound? And the reviewer believes that this is a very good question, because the characteristic sound can be defined in multiple ways. And the reporter had answered that the amplitude is what causes the characteristic sound, but not the frequency. But the reviewers don't believe with that, but we believe in the opponent that the characteristic sound is not mainly about the amplitude, but the frequency. And the opponent has asked that is SH simple harmonic motion suitable for this experiment? And the reporter said that yes, it is suitable, but the reviewer don't believe that simple harmonic motion is suitable for this experiment since it is too simple for analyzing a flat motion. And we have asked that, what do you think the most important factor in this phenomenon? And the opponent have answered that the volume of water is the most important factor, but both of them believe that volume of the water is the most important factor, and we believe in that. But we also consider that the flood speed is a very important factor. And we have asked that, do you think the water height will affect the amplitude or frequency? The opponent believe that they will affect, but the reporter believe that they will only affect the amplitude, but does not affect the frequency. And we believe the opponent because the reason why reporter didn't found a change of frequency because they use the same material, and the same material have the same natural frequency, so that's definitely will not change the frequency. And they all believe that the different material will affect the results. And that's all for my review. Thank you.
Ms. Porter, please conclude.
Okay, so for my final remarks, I will continue to reiterate that my results show that the volume of water does impact frequency. However, the height, because it keeps changing, it affects the amplitude, which also keeps changing. So to address the material issue, I don't have complete control over it, like I already stated in my presentation, which is why I'm making that constant, so it won't make an extra change in my data pool. And also, regarding the problem statement, I focus on the difference between moving versus not moving, because in the problem statement it says that the sound changes when the water in the bowl is moving. Explain and investigate the phenomenon. I interpreted that as trying to find the difference between the water moving versus not moving, which is why that was my main focus. And also, I feel like there is a misunderstanding between me and the opponent, because the opponent says that height of the water keeps changing, so the frequency changes. However, I think they also confuse that with the volume of water changing as well, which is not what's happening. That is it. Thank you.
Okay. So, any questions from the jury?
Well, maybe let me start with the presentation. Interesting problem. I'd like to ask you, what really caused the characteristic sound? Because it's without moving and moving. What really caused the characteristic sound of, for example, without moving? Is due to the air, water, or a ball? What do you think?
I think it's the water moving. That's the factor.
How about you?
I also think it is water moving, because by water moving, the water height, when we strike here, and the water here is high and here is low, so it will affect the
How about you?
frequency.
I think the material of the ball and the rotation of the water will affect the frequency, because the material is that they affect the initial frequency of the system, but the rotate of the water will affect the characteristics sound while it's moving. Like the frequency
So it's water or air?
water.
Water. Have you tried to fill up all the way to the top of the ball? Do you still hear the sound?
I didn't move it when I
I'm just trying to distinguish the water and the air vibration. Have you tried that? Because I didn't really.
The reason why I didn't do that was because if I filled the water up to the top and moved it, the water would spill, and that would impact the volume of water.
What do you think if you fill up water all the way to the top? Can you still hear the sound?
I think this one is a good way to control is all the water is it has caused frequency. But there's also a problem because the natural frequency of the material.
Well, I'm just trying to distinguish the main reason is due to the air vibration or water vibration.
Water vibration, because
The way you can fill up all the way to the top, then you don't have air, then you can compare.
But in this experiment, when you fill all the water,
Or
you cannot move the when you rotate the ball.
how about you want to comment on that?
Yeah, actually I have tried the different volume of the water, and I did fill the whole bowl with water, and when I strike it, it will have a very low frequency
Okay.
and not really clear sound.
So what does that mean?
So that means that the air inside that will generate the sound.
Any other questions?
Okay, you have a question? Okay, then maybe extend a little bit since we have
so
time.
maybe the jury prepare for this.
No, I can, we still have time.
Sorry. If you
So
have
if it's the air caused the main vibration of the sound, then when you move the water, all the water will disturb the air.
Sorry, could you please explain this?
We have to find what is really the main reason caused the sound. Is water or air or ball?
I still believe it's water because it's when you strike the ball. And also the air will change the frequency because the air is also shaking. But these two focus, I think they will affect.
Okay, you want to comment on
I
that?
think water is affect the character of the material, like because the wave is when you strike the material and they go through the water and then the air, so it will change the frequency, and when the air is generating the sound, it will affect by the wave that have go through the water. So the air generate the sound, but the water affect the frequency.
You want to comment?
I agree more with the reviewer's explanation because we also know that in my experiment the microphone is like in the air, it's not in the water, which means that it's detecting the vibrations in the air. However, the water, I feel like its importance is also as like a factor in the material, because its mass is included with the bowl, and that's why it's varying the volume.
Time is up. Thank you.
Okay, jury, please show the grading. Following reporter. 5, 6, 5, 4, 5. For the opponent. 7, 8, 6, 5. For reviewer. 7, 8, 7, 7, 7. Okay? So this section finished.